right, derivatives of hyperbolic functions. Well, they're all given to us here, but let's go show how it's done. Well, what I was planning for you is I was thinking, you know what, let's go take the derivative of sine hyperbolic of x, and let's go use the limit definition. You know, that we could go through and use what's given to us back here, our sum and difference formula. Go plug in and go get it this way. But I think there might be some easier ways of taking care of it. Well, why don't we just do it quite simply and just find the derivative on sine hyperbolic of x? Well, that's equal to taking the derivative on just 1/2 e to the x minus 1/2 e to the negative x. Know what I mean? I broke that into two pieces. Hopefully you're starting to catch what we have. But this was just a different way of us writing e to the x minus e to the negative x all over 2. These are the same things. But it'd be nicer if we could just go term by term. So let's do it. Once we find our derivative, we can say 1/2 e to the x's derivative is 1/2 e to the x. And then we have, and now we have negative 1/2 e to the negative x. So we're going to keep that negative 1/2. Derivative on e to the negative x is e to the negative x, but now we need to multiply by the derivative on negative x. That's equal to -1, so we change the sign of the center, and this is equal to cosine hyperbolic of x. So we've just shown that the derivative of sine hyperbolic is equal to cosine hyperbolic. Ding ding. Neat. You should probably try and play the same game right here with cosine hyperbolic. You try this one. And show it off just by using the definition of it, knowing that cosine hyperbolic is merely equal to e to the x plus e to the negative x all over 2. And you give it a shot. Well, let's go over and let's go prove. Actually, let's not use the word prove. Let's not get crazy. We're not going to use the limit definition here. Let's go show that the derivative of hyperbolic cotangent of x is equal to negative hyperbolic cosecant squared of x. So let's just say f of x is equal to hyperbolic cotangent of x. Okay, and we're going to use just two facts here. The derivative of sine hyperbolic is cosine hyperbolic, and the derivative of cosine hyperbolic is equal to sine hyperbolic. Just those two facts. But we can state beforehand that this is equal to cotangent. That's 1 over tangent, or how about this? Cosine hyperbolic of x over sine hyperbolic of x. And then I think if we want to do this, didn't we do it in class? We just used the quotient rule. So let's do it. Low sine hyperbolic of x times the derivative of high. Well, that's positive sine hyperbolic of x minus high cosine hyperbolic of x. The derivative on low, the derivative on sine hyperbolic of x is cosine hyperbolic of x. And we square the friggin' bottom, and we got it. So it looks like we have sine hyperbolic squared of x minus cosine hyperbolic squared of x all over sine hyperbolic squared of x. But we're trying to use our new identities here. And we don't have one for sine squared minus cosine squared, but we do have cosine squared minus sine squared. Hyperbolic, of course. So why don't we factor out a negative and see what we get? If we factor out a negative, we're going to get negative sine hyperbolic squared of x plus cosine squared of x. And then when we all over our sine hyperbolic squared of x, and if we just turn this around, we're going to end up with that cosine hyperbolic squared of x minus sine hyperbolic squared of x all over sine hyperbolic squared of x. And cosine squared minus sine squared, hyperbolic of course, is equal to 1. Hence we have -1 over sine hyperbolic squared of x, which is equal to negative cosecant hyperbolic squared of x. We did it.